In this final video on patterns, we're going to look at sigma notation. And just a reminder on how to do mathematics. Now make sure that you understand each step in the examples. You will not learn how to do maths by reading it or watching someone else explain it to you. Understanding the steps does not mean you can do it on your own yet. Therefore, to get the most out of this lesson, make sure to pause and do the questions before watching the answers. You improve your skills only through practice, but more specifically marking your practice sums and learning from your mistakes. So in this lesson, we are first going to start with evaluating the sum, and that's when n is small enough just to substitute it. Then we're going to look at evaluating the sum when n is a larger number, and then we're going to look at sum to infinity, then determining the unknown given the sum, and finally express it in sigma notation. So for example 33, it says that we have to evaluate this sum. Now this is the sigma notation, and it just represents that it's a summation symbol, meaning we need to take the sum of whatever is inside here, whereas your variable, it starts with this variable as 0. So this variable then starts with 0 and ends with 7. So that means you're going to substitute in. So if you should work this out, then you start by substituting in your variable from 0 and then adding it up until the last variable 7. So we're going to say 3 times 2 to the power of 0 plus 3 times 2 to the power of 1 plus 3 times 2 to the power of 2 plus 3 times 2 to the power of 3 plus 3 times 2 to the power of 4, and so on up until 7. Just going to continue here. Alright, so then we simply solve for this, or not solve for it, just work it out. So here we will have, this is then 3 times 1, so that's just 3, plus 6, plus 12, plus 24, plus, now it's getting a bit complicated, so now I've got 16 times 3, so that gives us 48, and then we have 3 times 2 to the power of 5 is 96, then 3 to the power of 3 times 2 to the power of 6, 192, and then finally to the power of 7, 384. Alright, so now we just add all of these up. Right, so that gives us 765. Okay, so that is done then. But this one actually, it is quite long. This one could actually classify as in the next section, where it might have been easier to do this using the method that we're going to look at in the next section. Right, now for question 33.1, first of all, we see that we have the sum of t plus 1 from t being equal to 1 up until 5. So I'm going to substitute in the values for t. So we've got 2 times 1 plus 1. Okay, so then plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1, and finally 2 times 5 plus 1. Right, so this then is 2 plus 1, so that's 3. That is going to be 4 plus 1, so that's 5. And then we have 6 plus 1, so it's 7. And then 8 plus 1 is 9, and 10 plus 1 is 11. So then I simply add these up. And that gives me 35. Okay, 33.2. So we're evaluating the sum of 2 to the power of r minus 1, r equaling starting at 3 and ending at 8. And substituting in, I've got 2 to the power of 3 minus 1, then 2 to the power of 4 minus 1, 5 minus 1, plus 2 to the power of 6 minus 1, plus 2 to the power of 7 minus 1, plus 2 to the power of 8 minus 1. Okay, so now I'm just going to substitute this into the calculator as is, just once off. So that's 2 to the power of 2. So we've got 2 to the power of 2 plus 2 to the power of 3 plus 2 to the power of 4, and then we just continue until the last term. Right, so that's the final one. And then our answer is 252. Then for question 33.3, evaluate the sum of negative 3 to the power of p minus 1, where p is equal to 0 up until 4. So we've got negative 3 to the power of 0 minus 1 plus negative 3 to the power of 1 minus 1 plus negative 3 to the power of 2 minus 1 plus negative 3 to the power of 3 minus 1 plus negative 3 to the power of 4 minus 1. Alright, so this then would give us, let's just substitute it in, negative 3 to the power of, so that becomes negative 1, and then it's 0, and then we have 1, and then we have 2, and finally we have 3. Okay, so that gives us negative 61 over 3. Okay, so that was the first section. Now let's look at a method that we can use to evaluate n, especially if n is large. So in this case, it says evaluate 15 minus 2n from n equals to 3 to n equals to 14. So if you realize that, and sometimes this one is also even small enough to do it the previous method. So in this case, it might be your choice, but sometimes you have up to 50 terms. Then you'll have to use this method. And with these summation sums, if you don't know what to do, always go to the first thing you must think of if you really don't know what to do is just get the first 3 terms. Because if you've got the first 3 terms, you've practically got the A value, the R or D value, depending on if it's geometric or arithmetic. And then you can, and once you have those, you can actually set up your formulas and find any number of terms, the sum or the value of that specific term. So if we start off, we're going to get the first 3 terms. So if I substitute in n equals to 3, so that's the first term. So my first 3 terms would actually be 15 minus 2 times by 3, and then plus 15 minus 2 times by 4, and then plus 15 minus 2 times by 5. Okay, so there's the first 3, and they are, if I simplify them, that is 9 plus, and then that's 8 minus 15 is going to be equal to 7, and then that is 10, 5. All right, so now we can actually find, because remember we need to find the sum of, and remember what is the formula for the sum of. Now first of all, before we can write down the formula, we must determine is this arithmetic or geometric. So first of all we find a, which is 9, but then we can see, okay, this is actually, to get the next term I have to subtract 2 the whole time. So we know, okay, this is arithmetic, so we write down d is equal to -2. Okay, now that we've seen that we've got d as -2 and that it's arithmetic, the sum of an arithmetic series is n over 2a plus n minus 1 d. Okay, and then we have a, we have d. We just need to know how many terms there are. That's the only thing we still need in order to get the sum of this series. So to get the number of terms, what you do is you take the top value, you subtract the bottom value, and you add 1. So you're going to say 14 minus 3 and add 1. Then we have that n is equal to 12. All right, and now we have all our values, so now we can simply substitute it in and get the answer. So it's 12 over 2, and then 2 times 9 plus n is 12 minus 1, and d is negative 2. Okay, so we substitute that into the calculator, and that gives us, I'm just going to write 6 instead of 12 over 2, so 6 times by, and then that's 18, the 2 times 9, plus, and then that is going to be 11 times by -2, close the first bracket, and our answer is -24. Okay, so just to run quickly through the steps again. First of all, when you see a summation, and the first thing you can actually run to always is just to get the first 3 terms, because that would tell you almost everything about your series, and because then from the first 3 terms you can get the A term, and you can determine if it has a common difference or common ratio, and then write that down. Then we see, when we write down, if we want the sum, we write down the formula of the applicable series, whether it's arithmetic or geometric, and then we see, okay, we only still need the number of values or number of terms, and then we can find that by taking the top value for n minus the bottom one and adding 1. Then we just substitute into the equation, and then we have our answer. Okay, so question 34.1. We have to evaluate the following. So the first thing I'm going to do is to get the first 3 terms. So 3, so t starts with 0 and goes up to 20. So 3 times by 0 plus 2, and then plus 3 times by 1 plus 2, plus 3 times by 2 plus 2, and then we carry on. Okay, so this is then going to be 2 plus 5 plus 7. No, that's 6 plus 2 is 8. All right, there we have our 3 terms, and from those 3 terms we can determine that A is 2, and we can see that we have to add 3 to get to the next term. So that means we've got a common difference of that's equal to 3, which then means that we have the sum of the series will be arithmetic. So we write down the arithmetics formula for sum of the series. So that's 2a plus n minus 1 d. Okay, and now just to find n, we say the top one, 20 minus 0. So 20 minus 0 plus 1, and that just gives us 21. And now we just substitute in the value. So we need to find S21 basically. So 21 over 2. And then 2 times by A is 2 plus 21 minus 1. And the D value is 3. Right, let's type that in. Right, and then here I'm just going to say 20 times by 3. 20 times by 3 is actually just 60. So I'm just going to do that. And and then we get 672. Alright, so question 34.2, we have to evaluate the following, and the first thing I'm going to do is just get the first three terms. So that means I have to say 2 times by 2 over 3 to the power of, now k starts with 3, so that's going to be 3 minus 1 plus 2 times by 2 over 3 to the power of 4 minus 1 plus 2 times 2 over 3 to the power of 5 minus 1. And then we just indicate that it goes on. And then we can just simplify this by saying 2 times 2 over 3 to the power of, so that's just 2. That gives us 8 over 9 plus, and then we can just change this 2 to a 3. That gives us 16 over 27 plus 4. Okay, so that's then 32 over 81. Alright, so the A value is then going to be equal to 8 over 9. And then the R value, since we've changed, every time the power just changed, so we can clearly actually see that the R value, that this is an R value because you just times it with 2 over 3 to get the next one, because the exponents just changed. Although, if it's not that obvious, just test, does it have a common difference or does it have a common ratio? So in this case, the common ratio is then 2 over 3. And since we have a common ratio, we know it's a geometric series, whereas the formula for a geometric series is then a r to the power of n minus 1 over r minus 1. And all we need is the number of terms, and that's easy enough to find. We just say 17 minus 3 plus 1. So this would then give us 15. Okay, so we need to find S15. And the A value is 8 over 9. Then we times that with 2 over 3 to the power of 15 minus 1 over 2 over 3 minus 1. Okay, now we'll have 8 over 9 Right, so that's 2,66. That's if I round it off to 2 decimal places. So you get 2,66. Right, then question 34.3. Evaluate the following. And here we're going to just find the first three terms again. And it is going to be 2 to the power of 2 times by negative 5 minus 1 plus 2 times to the power of 2 times by, so going up is negative 4 minus 1, and then 2 to the power of 2 to the power of times by negative 3 minus 1 going on. Okay, so the first term is then going to be, let's just type that one in. We've got negative 10 minus 1, so that's 2 to the power of negative 11. Yes, so this is 1 over 2048. And then the next one is negative 8 minus 1. So this is negative 9. That's 1 over 512. And then finally, negative 6 minus 1 is negative 7. And that's 1 over 128. 128. Okay, so A value 1 over 2048. The R value, we can actually see that if your variable is in an exponent, it's most likely to be a geometric, and when the variable is in a linear expression, then it's obviously going to be a common difference, but just always test it if you want to. So R is then equal to, so to take the second term, or we can actually start now with the third term divided by the second term, which is 1 over 512, and then we see a common ratio of 4, and we can test it with saying 1, or just double check it with 1 over 512 divided by the first term as 1 over 2048. Okay, so that is 4. Right, so now we need to find the sum of the series, so Sn, and since it's geometric, we have a to the times by r to the power of n minus 1 over r minus 1. And we still need n, so n is just 10. Okay, this one, just be careful with the negative here because it's going to be 10 minus negative 5 plus 1. And that then gives you 10 plus 5 is 15 plus 1 is 16. Okay, so we need to find S16, substituting in. A is 1 over 2048 multiplied by r, 4 to the power of 16 minus 1 over 4 minus 1. And then we can just find the final answer. Right, so this then gives us 699,050. And I think it's comma 67, rounded off to 2 decimal places. All right, so that's done. Now let's look at sum to infinity. Okay, so for example 35, it says evaluate. Now here we have r starting at 1, but here we're going up until infinity. So what we're going to do is just going to remember that this is a summation, and then if this is up to infinity, we immediately think of sum to infinity, and we have a formula for that, and the formula is the sum to infinity is equal to a over 1 minus r. So we basically need to get the first term and we need to get the common ratio. Now what we can do in this case is just to get the first 3 terms, and doing that we replace, we start with r equal to 1, so this is 2 to the power of 1 minus 1 plus 2 to the power of 1 minus 2 plus 2 to the power of 1 minus 3, and so on. So this is then 1 minus 1 is 0, so this just becomes 1, because anything to the power of 1, or anything to the power of 0 is equal to 1. And then we get 2 to the power of negative 1, so that becomes a half then. And then for the final one, we can actually type it into the calculator, although this is 2 to the power of negative 2, so that is then 2 to the power of, or that becomes 1 over 2 squared, which is then 1 over 4. All right, now in this case, we can see that our a value is simply 1, and then our common ratio is a half, because I take the first term multiplied by half to get the second, multiplied by half to get the third. And then all that I need to do is just substitute it into my formula for sum to infinity. So my a value is 1 over 1 minus a half, and then I just put it into the calculator. And that's equal to 2. Okay, so question 35.1, we have the same thing here. It says evaluate. Here we have I equal to 2, and then also up to sum to infinity. So first thing I'm going to do, once again, is just to get the first three terms. And then we're going to use the sum to infinity formula to calculate it. So my first term would be 2 over 3 to the power of 2, because I starts with 2, then plus 2 over 3 to the power of 3, plus 2 over 3 to the power of 4, and so on. Okay, so here I can actually, from here, we can write out the simplified forms, but we can actually clearly see that our A value here is just 4 over 9. If I simplify that, 2 squared over 3 squared, 4 over 9. And then my common ratio here is, can you see that each consecutive term gets just multiplied by 2 over 3? 2 over 3 squared, then 2 over 3 cubed, and so on. So my common ratio there is 2 over 3. And all I now need to do is use the sum to infinity formula, a over 1 minus r, and substitute in my a value. That's 4 over 9 over 1 minus 2 over 3. And then we just put it into the calculator. And then 1 minus 2 over 3. Okay, so that's 4 over 3. Right, so then we have 35.2. We have evaluate the following. K starts with negative 3, and then we have this formula, and it goes up to infinity. So first of all, I'm going to start by getting the first three terms. So we have 1 over 9 to the power of negative 3 plus 2, and then plus 2 times 1 over 9 to the power of negative 2 plus 2, and then plus 2 times 1 over 9 to the power of negative 1 plus 2. Okay, so first of all, this then becomes negative 3 plus 2 is negative 1. So this, if you type it into your calculator, you'll see this is to the power of negative 1, then it becomes to the power, take the 9 up. But just type it, if you're uncomfortable with this, just type it into your calculator. But we end up with 18, all right, plus, then this is negative 2 plus 2 is 0, so anything to the power of 0 just becomes 1, and then we have 2 times 1, so this is just 2, plus, here we have 1 over 9 to the power of 1, so that's just 1 over 9, we multiply by 2 and we get 2 over 9. Alright, now we have our A value as 18, and our common ratio, over here, if I say I take 18 divided by 9, I get 2 divided by 9, I get 2 over 9. So in actual fact, our common ratio is then I multiply by 1 over 9. So that's our common ratio. So then our sum to infinity will then be equal to a over 1 minus r. And if we substitute in our values, 18, 1 minus 1 over 9, and then just type it in. Okay, so we get 18 over 1 minus 1 over 9. And then we get 81 over 4. And then we're done. Okay, so that was sum to infinity. Now moving on to determining the unknown when we're given the sum. And these questions look as follow. Determine the value of n if we have this, well, it says that the sum of 22 minus 3k, where k starts at 1 up to n, this has to actually be a capital N, is equal to negative 602. Alright, so what we're going to do here is, first of all, as usual, let's get the first three terms. So we have 22 minus 3 times by 1 plus 22 minus 3 times by 2 plus 22 minus 3 times by 3. Okay, so 22 minus 3 is 19. And then we have 22 minus 6 is 16, and 22 minus 9 is 13. Okay, so now that we've established that, remember, now we can determine our A and our D or R values depending on what type of series it is. So A is 19, and I can see that I have to subtract 3 to get to the next term. So my common difference is then negative 3. Okay, now if we think about summation, and since we see that it's a common difference, we know it's the sum of an arithmetic series. So what is the formula for the sum of an arithmetic series? It's n over 2, then 2a minus n minus 1, or plus n minus 1 d. Alright, so a we've got, d we've got, and we even have that the sum is going to be negative 602. So the only thing we actually just need is then that n value. Okay, so we're going to now just substitute everything we have into this formula, and we're going to solve for n. So I have negative 602 is equal to n over 2, and then times by 2 times by 19, plus n minus 1, and the difference is negative 3. Okay, to simplify this, let's multiply both sides by 2 just to get rid of this fraction. Then I get 602 times by 2. So that gives me 1204, negative 1204 is equal to, now inside here I can simplify this. 19 times 2 is 38. Then multiply the n out, or the negative 3 into the bracket. We've got negative 3n plus 3. Okay, and then we just multiply out these brackets, and we can at the same time just add these like terms inside the bracket as well. So we'll have negative 1204 equal to negative, I'm just going to start with multiplying it with this guy, negative 3n squared, and then 38 plus 3 is 41, so that's plus 41n. Alright, and now to get it in standard form, we can see this is a quadratic equation. So bringing everybody to the one side, we have plus 3n squared minus 41n minus 1204 equals to 0. Okay, so I think the most practical and easy way to determine the value of n here is to use the quadratic formula. So you have minus b, so that's negative minus negative 41 plus or minus the square root of 41 squared, or negative 41 squared, minus 4. Then the a value is 3, and our c value is 1204, and I'm running out of space. Okay, so let me just do this over 2a, which is 3. Okay, so let's just substitute that in then. So I'm going to say 41, because the negative and negative becomes a positive. So 41 plus, and then the square root of negative 41 squared. So minus, and that is actually negative 1204 over here. So this minus and this minus will then become a plus. So this is then plus, and then 4 times 3 times 1204. Okay, and then that is over 6. Okay, so n is 28, or n is negative 43 over 3. Right, so obviously this one is not applicable. And then our final answer, so our n then is 28. Question 36.1. Determine n if we've got the following summation of 6r minus 1, where r starts at minus 1 and then goes up to n, and that is equal to 456. So first things first, we get the first three terms. So that is going to be 6 times by 1 minus 1 plus 6 times by 2 minus 1 plus 6 times by 3 minus 1. All right, now working this out, just simplifying them, we've got 6 minus 1 gives us 5, plus 12 minus 1 is 11, plus 18 minus 1 is 17. All right, now A is 5, and then our value for, is it going to be a common difference or a common ratio? If I look at whether I can see a common difference, I can see if I go from 5 to 11, I add 6 and then add 6 again. So I've got a common difference as 6. And then since this is now since we have a common difference, we know this is then going to be an arithmetic series. So let's write down the sum of an arithmetic series. So we've got Sn is equal to n over 2, 2a plus n minus 1d. All right, so what do we have? We have got the sum of 456, and then we also have the a value and we have the d value. Now another thing I failed to mention in the example is if r is 1, this is quite simple because your first term is your first term, and your n will be then the amount of terms you have. But if r is not 1, then you have to remember that your n value will be the top, so n minus 1, or n, top minus bottom, so that would be like n minus r plus 1, right? But this is only necessary if we have not got a 1 over here. Okay, so just keep that in mind. Then you'd find n here and then just solve for the big N. Okay, so now since we have everything except for n, we have to then we just substitute and solve for n. So we substitute in 456 equal to n over 2 times by 2. A is going to be 5 plus n minus 1, and d is 6. Okay, simplify. Let's start by multiplying both sides by 2. I've got 456 times by 2, so that's 912 equal to n. Then I've got 10 and multiply the 6 in, gives me plus 6n minus 6. All right, and then simplify it further, 6n squared, then that becomes 10 minus 6 is 4, so it becomes plus 4n. And then just put it in standard form, say 6n squared plus 4n. If I take the 912 over, becomes a negative 912 equals to 0. So I just basically wrote everything that's on this side. Okay, now we can maybe simplify this a bit by dividing everything by 2. We get 3n squared plus 2n minus, this is just going to go back to 456 equal to 0. And then let's substitute it into the formula. So n would be equal to negative b, so that's minus 2, plus or minus, then the square root is 2 squared minus 4, a is 3, and c is negative 456. And that's all over 2a, so 2 times by 3. Okay, now simplifying it, we've got negative 2 plus, so that's going to be 4, and then we have minus and minus becomes a plus, so then I'm just going to type in 4 times 3 times 456. You could obviously just type everything as it is. that's safer for you. Okay, so then it's 12, n equals to 12, or n equals to negative 38 over 3. Okay, so this guy, not applicable. And then this is your final answer. Now, let's say that your R was not 1, okay? What would you do if you've gotten to this point? We solved for n now, okay? Then we'd solve for n here, and we then substitute in our n value into this equation where we found the number of terms. So if we see that our number of terms is 12, what would be the capital N? I'm just going to do it over here. So we've got 12 for the small n equals to n minus, and our R is 1, and then plus 1. So in this case, since R starts with 1, it works out the same, that n would be equal to 12. Right, so question 36.2, what is the greatest number of terms for which the summation of k plus 2 from k equals to 1 up until n will have a value less than 68? So now you have to think carefully, what are they asking here? Value less than 68, meaning this summation must be less than 68 basically. Okay, so what we're going to do is we're going to follow exactly the same procedures with whether it was equal to, and then we're just going to use logic to determine where it's going to fall, because this might, our n value might not be a whole number in this case. It might be decimal places, and then you're going to have to see, is it going to be like, if it's 3,5, will it be 3 or will it be 4? Okay, so first of all, as usual, we just get the first 3 terms. So k starts with 1, so you have 1 plus 2 plus 2 plus 2 plus 3 plus 2. That goes on. Okay, so we have 3 plus 4 plus 5. Okay, a value is 3. Then we've got a common difference of 1. Just add 1 the whole time. Okay, so this is really a very simple series. Now we know we have to get the sum of, since we have a common difference, we know we have to get the sum of a arithmetic series. And before we carry on also, let's just remind ourselves that our n, then the number of terms will be the large N minus your k value plus 1. Okay, let's just put that into our general steps, just for in case k ever happens to not be equal to 1. Okay, so Sn, since we have an arithmetic series, is n over 2, then 2a plus n minus 1 times by d. And now we can just substitute in everything we know, because we know that our sum must be less than 68, but I'm just going to solve it for 68 so long. Now remember, if you've done the previous videos, in this case where we have an inequality, you've got 2 options. You can actually substitute the inequality in and solve a normal inequality equation, or you can solve it as if it's equal to this and then just use logic to determine which is the value at the end of the sum. Okay, so I'm going to substitute in 68 equals to n over 2. So 2 times by a is 3 plus n minus 1, and d is then 1. Okay, simplifying, multiplying both sides by 2 first. We get 136 equal to n, and that's 6 plus n minus 1. Then multiplying the n, 136 equals to n squared, and then plus 5n. And then we put it in standard form, n squared plus 5n minus 136 equals to 0. And then we substitute it into the quadratic formula. So n is equal to negative b, so minus 5, plus or minus b squared, so that's 5 squared minus 4. A is 1 and c is negative 136. And that is over 2 times by a, 2 times by 1. So in this case, we've got n equal to negative 5 plus, so that's 25. And then minus and minus becomes a plus, and then we're just going to say 4 times 1 times 136. And that's over 2. Okay, so this is then 9,43, or n is equal to negative 14,43. Okay, so we know we do not have a negative term number, and therefore we've got n equals to 9,43. Now, this is where we now have to determine, is our n value our number of terms, is it going to be 9 or is it going to be 10? Because we don't just round up or down with patterns or with finance sums. We have to determine if we have exactly 68, the value. To get exactly the value of 68, you have to substitute in your 9,43, then you will get exactly 68. But to get something smaller than 68, since this increases the whole time, when you add another term, it increases. So to get something that's smaller than 68, you have to go to the term number right before 9,43. So therefore, our n value will then just be equal to 9. If this said greater than 68, you'd have to get something bigger than 9,43, which is 10. So now if you have this formula over here, you can just take your small n, because remember your small n represents the number of terms. So where your big N just represents up to where your k value actually goes. So when k is 1, your number of terms and the n value will correspond. They'll be equal. But if k is not 1, your number of terms will be different than this value here. So I'm just going to go and say, okay, n is equal to the big N. Okay, so n's value, which we got now, is 9. So n is equal to the big N minus my k, which is 1, plus 1. So therefore, n is equal to 9. Okay, so then question 36.3. What is the greatest number of terms for which this summation 3 times 2 to the power of k minus 1, where k starts at 2, going up to n, will have a value less than 89. Alright, so first of all, let's start with getting the first 3 terms. So we have times 2, k is now 2 minus 1, and then plus 3 times 2, 3 minus 1, plus 3 times 2, and that becomes 4 minus 1. Okay, so this is then 3 times 2 is 6, plus 3 times 4, which is 12, plus 3 times by 8, so that's 24. Okay, so I can see, and which also gives me a good indication that this is a geometric, is because the n, or the variables in the exponent. So my a value is 6, and then I can see that I have to multiply with 2 to get the next term. So my common ratio is 2. And then let's write down that our n is the big N minus k plus 1. Okay, the top one minus the bottom one plus 1. Okay, so now to get the sum of a geometric series, what's the formula? The formula is Sn equal to a times by r to the power of n minus 1 over r minus 1. Okay, and we have a and r. We just need to solve for n. We also have Sn. So I'm going to substitute in 89 equal to, so a is 6, and then r is 2 to the power of n minus 1 over, and r is 2 minus 1. then to simplify, this just becomes 1, which then would then just simplify to 6 times by this. Then we can just divide both sides by 6, because I want to actually just get this on its own first. So 6 goes up, 1 you can say goes up, multiplies, doesn't really matter. So what I'll be left with is then 2 to the power of n minus 1 equals to 89 divided by 6. Okay, that doesn't simplify much. So we've got 89 over 6. Then take the 1 over, so 2 to the power of n is equal to, we'll have 89 plus 1. So you just say that plus 1. And here we get 95 over 6. Okay, now we are here at another point where we can see that we have an exponential equation to deal with here, but we can't change this. This won't change into a base of 2, because with the exponential equations you normally have to change it to a base of 2. So, or the same basis and then drop the basis. So if you can't do that, you have to use logs. So we log both sides, and then we use the law of log, where we can say this n has to go over to the front. So n log 2 is equal to log 95 over 6, and then we can divide both sides by log 2. So log 95 over 6 over log 2. Okay, so let's work that one out. So we have just our brackets, then log, then fraction, log, fraction, 95 over 6 over log 2. Okay, so that gives us 3,98. All right, so now that we've determined n to decimal places, we need to know now, is it going to be 3 or is it going to be 4? And since this says we have a, for this value, to have a value less than 89, and let's look at what this series looks like. We are, with each consecutive term that we add, it's getting bigger and bigger and bigger. So therefore, the number of terms with lesser number of terms, you'll have a smaller value. With more number of terms, you have a bigger value. So if we have to be, if 3,98 gives us exactly 89, then to have a smaller value than 89, you will have to have a smaller number of terms. So between 3 and 4, your answer is actually going to be 3. To get something less than 89. So therefore, we have our n as equal to 3. Now, since we have this n, but we need to solve the big n, all right? So we substitute in all our values. We've got 3, just going to write here, we've got 3 equals to my big N minus k, and k in this case is 2, so minus 2 plus 1. Okay, and then this becomes negative 2. So if we take this, if we solve for n, then we basically have negative 1 here goes over and it becomes positive, and then we have 3 plus 1. So n is then 4. Okay, so that was that section. Now off to the last section. For example 37, it says write the following series in sigma notation. Okay, now the first thing we need to know about sigma notation is that we have our sigma notation, and then what is inside here is your general formula for the term, number of terms, the Tn. All right, so then you're going to have to go back to the first parts that we did, where you just find your general term for either a geometric or a arithmetic series. So then at the bottom you'll have, and when you set up your own sigma notation, always just say that it's k equal to 1, or you can actually decide what variable. You can use any variable that you like, and then we need to find a number that it goes up until. So this value, these, remember, you're going to find your general. If we found the general term, and let's first decide what is this. This is actually a geometric series where we multiply with 1/2 the whole time. So our a value is a half, and our r value is also a half. Okay, so that's also the first thing you go to when you have to find your general term. So we know for an geometric series, Tn is equal to a times r n minus 1. So now we can just substitute in our a and r value. So that's going to be half times by half to the power of n minus 1. And that's how we found from the beginning, we found the general term. So now we simply take that general term. This is what comes into this notation over here, is your general term. Then you have one more thing to do. You have to find this value up until what value this goes, and this is your answer over here. Now this is the term value, the actual term value. You need to find at what position is it, what is its n value. So obviously we can use this as well, our general term, to solve for that. So if we substitute in 1/128 is equal to a half times by half to the power of n minus 1, and we solve for that, we can say we can multiply both sides by 2 to get rid of this half, and if we do that, we get 1/128 times by 2, and that's 1/64 is equal to a half to the power of n minus 1. Now, I just need to get the same basis. So this 1/64, I need to change. I'm just going to make some space here. I need to change that into the same base as a half to the power of something to get me 1/64. And I think actually it's to the power of 6. We can just say a half to the power of 6. So that gives me 1/64. So this is then to the power of 6, which is equal to 1/2 power of n minus 1. And then drop your bases. So 6 is equal to n minus 1. So n is equal to 7. All right, now since our k value is 1, our small n will correspond with the big N. Our number of terms will correspond with where it goes up until. So we found our big N then to be 7, and we can just substitute in the value for, so 7 is our N, and K is equal to 1, and then we just substitute in our general term here into the sigma notation. So this is then a half times by half to the power of n minus 1. Okay, so this is then the final answer. This guy over here is putting this into its sigma notation. So first thing we did, find your Tn value. You can actually write this down as a general format for yourself, because you see you have to find the general formula for the Tn, and that you just do by finding if it's arithmetic or geometric. We've done that in the very first video, just finding the general formula for Tn, and then you need to find n. You use your general formula with the last term that's given, solve for n, and since we've put k equal to 1 as our first one, our n will be the same as our small n, and we just substitute in those values, and there we have it. Okay, the following series, write the following series in sigma notation. Alright, now this one is actually pretty easy. They actually just give us the n straight away. We can just count them. So if I start by, and here we have that our a value is 7, and to get the next term I have to add 3 the whole time. So our common difference is then 3. Now that I know, and also what I missed now is we can actually just start by writing this down, k equal to 1, and then Tn. So we know Tn is the first thing I want to find. So I need my a and my d value, in this case, since it's arithmetic. Now for arithmetic series, we have that Tn is equal to a plus n minus 1d. Okay, and then substituting in my a value, 7 plus n minus 1, and my d value as 3, and then just simplifying that, we get 7 plus 3n minus 3, and that is then, Tn is then equal to 3n plus 4. Okay, so this is where we got our general term, and that is once again from the first part. You've started doing this in grade 11. Alright, so now we know what to substitute here, and then just to find the n value, and in this case we can just see, okay, there's 1, 2, 3, 4, 5, 6, 7. So n is 7. Now to find my sigma notation, I just say, okay, k is 1, and then I have to actually write it in terms of k. That I did not do in the previous one. So here we're not going to say 3n, we're going to say 3k plus 4, and then that is up until 7 terms. Right, question 37.2. Write the following series in sigma notation, and that's 2n terms. Okay, even easier. Alright, so my a value is 3, and I see I've got a positive term, negative, positive, negative. So, and from 3 to 6, I can multiply it with 2, multiply by 2, multiply by 2. So my r is then negative 2, okay? And then I can see that I have a geometric series. So my for my summation, Tn will then be geometric up until n term. So you can just maybe make that n, k equals to 1. So if I say Tn being a geometric, it will be a times by r to the power of n minus 1. And then substituting on our values, we've got 3 times by negative 2 to the power of n minus 1. Okay, this is then our general formula, Tn. And we don't have to find how many terms there is, it's just up to n terms. So then to substitute it in here, we've got up to n terms, where we start with k equal to 1. And then instead of saying 1, I'm going to say 3 times by negative 2 to the power of k minus 1. Okay, then 37.3. Write down the following series in sigma notation. Okay, this is actually kind of a special case because we won't get a common difference here. You won't get a common ratio either. So we might, actually let's test it. Let's see if we would get a common ratio. If I say 2 over 3 divided by term 1, which is a half, I get 4 over 3. If I say 4 over 3, 3 over 4, divided by 2 over 3, we get 9 over 8. So no common difference, no common ratio. Now you have to kind of look for something else that stands out. Now we can see that this is 1, 2, 3 up until 24, and here we can see 2, 3, 4 up until 25. So this actually, in this special case, we've got a series in the numerator and a different series in the denominator. So what we're going to do is, first of all, we are looking for a summation with a Tn, and then we're up until a certain number of values where k starts with 1. Okay, so to find the a value, so let's say for series, the series at the top, the a value is 1. So let's call that series 1, and this one series 2. The a value for the bottom one is 2. Then the d, it's got a common difference of 1. We actually don't have to go through this procedures either, but let's just do it. So d is also equal to 1 here, because if I look at this is what's going to work out here. It's just going to be n. So we've got it's a arithmetic, so Tn is equal to A plus n minus 1 d. And if I substitute in everything, I get 1 plus n minus 1 times by 1. And then if I simplify that, I will end up with n. Okay. And then on this side, we have Tn is equal to 2 plus n minus 1. And our d is also 1. Then we have 2 plus n minus 1, so we have n plus 1. Okay, so our Tn then will be, our general term will be for the numerator n and the denominator n plus 1. Okay, this you could have actually seen. We could have seen that for the first term it's 1, for the second one it's 2, it's third is 3, so n is the general term. Otherwise, just follow these procedures. Okay, so now to get to the number of terms, we can actually use, if this is just n, we can see, oh, it goes up to 24. So our big N value is then just going to be 24. Even for this one, if I say the 24th term and I substitute it in, I get 25. Okay, so now we could just substitute these things in. If k is 1, then up until 24 terms, then we can say it's k over k plus 1. And then that would give us this summation. Okay, and then we are done.